Howdy, howdy, howdy. I have looked into it. Haven't particularly done much with it though. Generally, you would want it if you need like performance, real computer type of stuff rather than dealing with Python's interpreter. Why, out of curiosity? Any particular reason you need it?
You unlock this door with the key of imagination. Beyond it is another door. This door is another dimension. A dimension of sound. A dimension of imagination. A dimension of doors. You're moving into a land of both shadow and substance, of things and ideas, and substance, of both shadow and ideas, of things and a dimension of sound, a dimension of mouth.
Scython would definitely be one way to do that.
Of things and ideas. A land of doors. You've just crossed over into mouth dreams.
Out of curiosity, dial this back a little bit. Is it something? Is it something that you can multi-process? Like, can you thread it out rather than going Scython, or is that required? In order. Spell. Accordance for Bezier. Look into Neil Cicierega. He is amazing. He did the Potter Puppet Pals way back in the day. It gets better. This is he does mashup albums now. Could do this one. You know, I won't judge. I've got a the fact that I'm actually considering it's kind of funny. So there's the album. If you're taking a break day and listening to this and not listening to me, I'm not gonna get upset. I think I'd probably get in trouble if I just streamed mashups all class. It is that kind of day outside though, huh? But yeah, he did this thing way back in the day.
What is that mysterious ticking noise?
Good stuff. We should probably talk about UML, though. Sorry. Like I said, I'm not strictly looking over your shoulder right now, so if you need a day, that's fine. I'm joking. So, we ended about here last time, for those of you that are not muting me, I suppose. So keep in mind, next week we have our midterms starting on Wednesday. We'll do Blackboard Collaborate for those. I'll post an announcement and a reminder and all that fun stuff so that nobody forgets. Won't be on Twitch. It'll be in Blackboard so that you can all talk and I can listen to all of your melodious voices and not this horrible nasal monotone that you get from me. But yeah, should be fun. I'm looking forward to seeing what you've all come up with. Been getting some people asking me questions and clarifications, so kind of getting a taste for where you're at, and I'm excited to see what you all come up with. So, where did we end up last time? We were talking about stuff that is not as fun as internet memes and more about making good software. I'm sorry, it's reality. You take your lunch break at work, watch fun YouTube, and then you have to go back to work for a couple hours and then watch some more fun memes. So pretend like it's a real normal day. But we ended up here, right? So we had our sequential sequence diagrams. We have our classes. We have our objects. And again, these look a little bit different than some of the other ones, right? Actor, entity. We can represent the classes and actors and objects depending on what you want to show. This is probably a more common view. This would be a more formal view. Both of them are okay. But they have the lifelines, right? They have the execution instances, methods or messages, and everything in between that we need. And we left off here, right? So I think I was talking about guard conditions. Ah! The hell was that? Sorry. Are these working? So I don't know if anybody else heard that. I just got this like horrible shrieking sound in my left ear. I don't know what the heck that was, but that was very loud. Okay, let's not let that happen again. Okay. Wow. I really hope not because I just bought them last year. Okay, we're good. All is good. So we talked about this stuff, right? And did we talk about guard conditions? I can't remember if we did or not, but basically these are your if statements on your message paths, right? So if we have this bank interaction here and we have to put in a debit card, right? This is the excuse everyone looks for to buy a new pair. Yeah, I think I was popping into the general CIS Discord, putting my opinions on headphones, and I was saying how much I like these ones, and now they're shorting out on me. So I'll have to go back and look and see what everybody else is using. I will say I had Bose headphones for years, and I decided to try Sennheiser's because back in my radio station days when I was an undergrad, Sennheiser was another really good brand. But we'll see. If it does it again, I will check under warranty. Absolutely. So, your if statement. Can this method be invoked? If card exists, then put in card, right? So these are going to be constraints or guards to make sure that you can actually go down this path. We have them with class diagrams, with state machines. Basically, again, they are effectively your if statements. It doesn't have to be if else. It can be if, elif, else, and then message. I think we talked about guard destruction as well, right? So if for some reason this object, for instance, gets destroyed at some point in the process, put an X at the bottom, and that shows that it goes out of life. So like here, this masterpiece class gets instantiated, it's alive, it's alive, it's alive, and then it gets destroyed by another processor by itself. So we would indicate that with the X. Makes sense, I hope. Last thing to talk about here is this frame. So this context basically shows you exactly what the overall environment is that we're modeling. So if you look here, we see make appointment use case, right? So we are actually modeling a particular use case from our use case diagrams. So again, make appointment would be the use case from the prior diagram that you created, where appointment could be a class, right? And we actually see that right here. Appointments are class. Make appointment, we don't actually see the invocation, but there'd probably be a method called make in there, or it's probably actually create appointment, but we can hopefully start to see how everything fits together with this model. So here is another view. We are getting this collaboration, this sequential interaction of all of our objects in our system. And if you don't remember from last time, the way you read these, you start at the top left and you follow the arrows. Once you get to a focus of control or an execution instance, basically, you go down a little bit. So receptionist is active at this point. I request an appointment. I put in my parameters. It goes to the receptionist actor here, who then looks up a patient, right? And looking up a patient interacts with the patient class and instantiates the a patient object, which is tied to this actor. It's not, the only thing that's really spelling that out is that the name is the same here, right? A patient, a patient. So we have a logical instance of a actor in this case. But if this patient exists, ideally we would return that object back. We have a guard right here. A patient exists. And then if they exist, we can do other methods, right? We can look up their bills. If this patient does not exist, they would have no bills. So they wouldn't go down this path of execution. And then we can go and touch the other classes in the system as well, right? We can try to make an appointment match. If we have a matched appointment, right? The a patient actor and the a receptionist actor come to an agreement on date and time, then we can create an appointment. Now, one thing that you don't really see on here is the return values, or are the return values. Depending on your model, it might be considered expected that if you create an appointment, you will get an appointment object back. Or if you match appointments, you will get a Boolean true or false back. It just kind of depends on what you're trying to communicate with this model. If it were me, I would spell out exactly what's being returned. But depending on how detailed you want your model to be, you can kind of hand wave some of the obvious like return values and so on. So typically you would have something coming back, and if you remember, it's a dashed arrowed line coming back. One other thing to keep in mind here, so all of our arrows have been basically pointing rightwards so far, right? The solid lines have been pointing right, and the dashed arrows have been pointing left. Like in our other models here, goes right, return value is left, return value is left. It is possible to have method invocations go the other way too. Nothing wrong with this. The only reason I wanted to point it out is that none of our examples had that, and I didn't want you thinking that they can only go right. But if a receptionist has to do something with a patient, right, figure out what the appointment times are, create a new appointment, cancel or change an appointment, it can point left as well. It doesn't have to be a return value going that way. Again, hopefully a common sense type of thing, but I don't necessarily want to assume that everybody gets that out of it, because if all you ever see are right arrows, then you might assume they're always right arrows. But that's not always the case. Hopefully sequence diagrams make sense though. If anybody has any issues or questions, please feel free to let me know. But now we're going to talk about how to build them, and then we're going to go into communication diagrams. So how do we build them? First, set the context. What is the context? Well, it's that thing that we are modeling. Could be the use case, right? We are making an appointment. We are getting money out of an ATM. We are performing collision detection in our game. We are instantiating a world. So what is the sequence you are laying out? And what do we care in this? Again, care about who is participating, either people or classes or objects or entities of any kind. and we want to know how they relate to each other. And you can take this and apply it to your coding, where we know that a patient is only ever interacting with a receptionist. A patient doesn't talk to the booking system. A patient does not talk to, the nurse behind the scenes. A patient only talks to the person at the front. The person at the front acts as an interface to the rest of the system. Hopefully you can see how by kind of breaking up and clearly specifying relationships, we can actually inform our coding with it. So we set the context, we figure out who's interacting, then we set our lifeline, right? And the lifeline is this vertically dashed line here that says when this particular object is active in the system. And if they are something that's instantiated, we put an X when they go out of scope or when they get destroyed, right? So these are all assumed to be there the whole time. However, if we are creating a new appointment and we are then canceling it right away, and we have like a cancel appointment method, then we put an X there to show that it's no longer in scope, right? We don't care about it anymore. It can't be talked to. So then after that, add your messages, draw arrows, clearly indicate direction and what the messages you're passing, add any guards or constraints that you need to actually call that method, and basically show who is interacting with what. And the last step, well, second last step, add your execution occurrence or your focus of control. It's a little skinny rectangle here that shows that this particular object is active at this particular point in time, right? We are performing some kind of an execution in this box. Now the rest of it, the dashed part, we're still alive. Nobody's talking to us, right? However, when this box is there, we are doing something. So think of this that you are active in memory but not being called. Here we are active and executing. Last step, validate it. We haven't talked too much about validation, but basically what you're doing here is you're looking to see if it makes sense or not. All right, are all of your objects there that need to be there? Is somebody missing? Is somebody extraneous, right? Is every entity there supposed to be there? And with that, do all the relationships make sense? Should the patient only talk to the receptionist, or should they be able to go into the system at home, right, and log in remotely and pay their bills? Or do we have this interface of a front end that then handles all the interactions later on? So for validation here, you can basically step through and figure out if things are good or not. And with validation, you also would tie this back to your use cases, your class diagrams, and basically all of your diagrams and see, do we have consistency, right? Like if we have actors in this interaction that do not appear in any of our other diagrams, then there's a problem, right? Why isn't a receptionist in our use case diagram for make appointment? It's here. Clearly we need a receptionist, but in our other model way back when, we never considered this person as there, or this unpaid bill class, or this appointment class. It kind of gets back to that idea of traceability and making sure everything links up. If you start seeing inconsistencies or holes or too much information, then there is a problem somewhere. And the issue is that will get reflected further and further and further on down the line, and it has to be resolved pretty much when you catch it. Otherwise, it becomes a major headache for you, and we don't like headaches in engineering. It's a problem. So, we are good. Earlier in class, I had my my little head right here, and it looked like I could just... there we go. Perfect. Then I moved up here. It's fun to slide around. So that's sequence diagrams. Now, we're going to talk about communication diagrams. This is the other behavioral diagram we're going to talk about. And it is semantically equivalent to a sequence diagram. And what that means is that both sequence and communication diagrams convey the exact same information. You can generate one from the other without losing any data. Right? Like if I generated a class diagram from a use case diagram, or I generated a state diagram from a class diagram, I don't have necessarily all the information in one versus the other. Right? Like use case diagrams are very broad, very high level. class diagrams are very focused, very specific. There is a disconnect in the amount of data. Whereas here, this is the exact same information. Now, why do we have two diagrams that do the same thing? Is a good question to ask. Basically, they give you different perspectives on interaction, on communication, on who is talking to what object. Right, so what do we have in these diagrams? We have paths and we have sequence numbers. So this is basically, again, lines from object to object. We also have a sequence number, which is new. So this is basically the order of the message. So it goes sequentially, 1, 2, 3, 4, 5. Message 1 runs first, message 2 runs second. Makes sense. But if you start seeing diagrams with numbers on them, you might not realize what they are. And there might be, maybe it's an ID, maybe it's an order. Without context, we don't know what it is. So what does it look like? And this diagram's okay. I'm going to show this one first. A little grainy, but it's a figure from another textbook. So this is the exact same diagram that we had before. Right, so a patient, a receptionist, patient and a patient object, unpaid bill, appointment. All of the methods here, these all existed in that other diagram. Right, so let me go back here. Exact same entities, exact same function invocations, even down to the guard condition on lookup bills. Right, still there. The differences here, though, are this is a lot cleaner to read, right? There's not as much going on. We have a different perspective. And what do we get more out of this model? We see very clearly, with like no ambiguity, which object talks to which object. Right? If we go back here, we can kind of get it. It makes sense, right? Patient talks to receptionist, blah, 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 blah. These all talk to each other. But then we start seeing like lines overlapping. We have, kind of a lot of back and forth here. Still a simple diagram, but it can get more complicated and the connections can get a little bit fuzzy in a way. But here it's very clear, right? These two are directly related. A patient never talks to any of the other ones. A receptionist is effectively the interface between everybody here, right? We have a single point of entry to all the other classes. But the difference here is that we see these numbers next to each method, right? So this is item 1. Then item 2 gets called, then item 3 gets called, then item 4, item 5, item 6, item 7. All right, so we get the exact order here. Other thing that we see that's different, we have an arrow, right? So we don't have any arrows on the lines in between objects. We have the direction attached to the function call here. And the reason why is that if you look at this example, we see that it can go both ways. And you don't want this line to be bidirectional because it'll be very ambiguous which way a function is supposed to go. So if you're going to do this kind of a model, you have to basically indicate the direction for each function that you're creating. But on the whole, this is a little bit cleaner, but there's nothing stopping you from using a sequence diagram as well. It depends what you want to communicate and what you're comfortable with in a way too. All right, so we're showing the dependencies, we're showing the message passing relationships, and we're really emphasizing that relationship flow. So here we have the exact same model. Well, not exact same, we have the same type of model, except this is a librarian working with a book checkout system. We don't have a person trying to borrow a book, but for instance, we are trying to see, does a person have a book already checked out? Do they have any unpaid fees, or is the book overdue? Do we have to create a fee if it's overdue? Things of that nature. Ideally, you can get kind of a feel for what's going on here. The difference, though, and why I've got these two different types of diagrams, here we actually have return values. This one does not have any return values. So if you remember when we looked at the sequence diagram, I said, they kind of hand wave away the returns. Like we assume that if a bill exists, it would come back, but we don't show it. Right? Same thing here. We don't see any return values, but here we do. So it's kind of a good separate example to look at. So for instance, here, let's say that this librarian's checking out our system, going through the user interface, performing a transaction about a book. we're figuring out if it's overdue. Okay, so we've got a little loop here that we're checking out our media, or seeing what's checked out. Is it overdue? If we find something is overdue, we can return the ID and create a fine going this way. So you see the different arrow type. This one is a solid arrow going this way, straight up method invocation. You see the empty arrowhead coming back, or going different directions even. It doesn't have to necessarily go back, but this is a return value. Again, it looks like, go back here, this would be your return value, right? So again, we're modeling the same information. We're just showing it a different way, and we're actually showing what the data coming back is, which I would prefer if it were me. You know, I would like to know what the actual data or the variable name and variable type is. But it's basically up to you as the UML designer on how much information you want to show. All right, so we have this, and then I've just got one more view here with a slightly different perspective on this type of diagram, but basically they just have every entity spelled out and defined here. Slightly different names though, so they call an actor a lifeline. Lifeline name, this would be your object ID. Class name, you know, this would be a class. This is technically an actor. Lifeline name. I mean, they're basically just actors and classes, right? So how do we build these diagrams? Again, set the context, exact same process as sequence diagrams, basically. Which use case are we modeling? What instance are we trying to get a feel for the flow of? Who is participating? What are their associations? Lay out the diagram, add messages, validate the model. One thing I didn't really talk about was laying out the diagram, though. So we have simple models like this. Pretty easy to lay out, right? We just kind of go in order. Nothing too complicated here. But start thinking of if you have a more complicated diagram. Laying out the model becomes a little trickier, right? Because you want to avoid overlapping lines. You want to avoid giving the maybe false pretense that somebody is the center of the diagram, right? Like if we put a patient right in the middle of the model and then we have a short line to a receptionist and we kind of spray these classes out around a receptionist, there's nothing syntactically wrong with that, but it's hard to read and it's hard to understand. So basically the point is just lay these out kind of intelligently. Don't have any crossing lines or, you know, information that gets obscured because you have too much. So just be careful with laying things out. Add your messages. So again, add the function calls, add the IDs or the sequence numbers for them, then validate it again, just make sure it makes sense. So that is it for UML for now. Does anybody have any questions on this? Otherwise, we'll pop over to design patterns and get that fun stuff unrolled here. Please, thank you. I'll say I like Google Slides, except I would prefer it to not pop up the notes part right in front of you when you present. It's a nice thing about PowerPoint is it automatically realizes you're doing two displays. Although there's a plugin for that now. Okay, so design patterns. You're either going to love this or hate this, and I will say that with experience. Design patterns are complicated concepts. They are tricky, they require abstract thinking, but they can save you oh so much time if you figure them out and implement them correctly. And take this from somebody who admittedly prefers to use brute force programming over anything tricky or elegant, somebody who prefers his code just to function and will worry about the niceties later. If you apply a design pattern early on, it saves you so much time and effort that it's ridiculous. So what are design patterns other than nice excuses to use abstract art that I find in Unsplash? These are basically things that are patterns that have been observed over time in software design. Right, so we have since what, the 60s, 70s worth of coding implementation, various languages. Obviously, more recently, we have the object-oriented stuff has really come to light. But many, many industrial cases, many, academic cases of here are all these very, very common problems that people face. Think of separating out view from control or having an interface to an internal group of entities. Basically, all of these kind of common things which we take for granted that we're just going to implement by hand and then let it roll, there's probably a pattern out there which will make life easier. And when I say make life easier, at the outset, it might be trickier. So you have to put a little bit of effort in to implement these things. But what do you get? You get very easy extensibility, meaning you can very easily add on components or extend things without tearing up the whole project. Or you get maintainability, or there's a lot of benefits to doing this, but they're complicated to consider. So we have some different categories of these things, and we're going to talk about 3 of them. So we have the creational, structural, and behavioral. We'll talk about what these categories mean. I've got 3 examples, both in Java and in Python. We'll probably won't get to those until Monday, but basically I want to kind of introduce you to this field if you've never heard of it. And if you have heard of it, we're going to augment that. Now, out of curiosity, has anybody ever seen this textbook? I showed my grad students this book this week in another class, and they all kind of groaned when they saw it. Any of you ever checked this book out by chance? I'll take the res. Do I recommend it? Ooh, that's a good question. I would recommend it if you want to learn about design patterns. I will say though, like any computer science topic, there are many resources on the internet that basically have everything in this book that you need. There might even be PDFs on the internet if you don't want to buy it. I gave this to one of my former grad students for a qualifying exam and made him learn a bunch of design patterns because he needed that for his tool belt basically. But it's very well written and very well spelled out. It's almost like a dictionary of design patterns. When I was teaching system administration, we had a textbook that I used as kind of a recommended material. It was like the Linux Bible, and it was basically just every Linux command you ever needed with different examples. This is basically the same thing, but for design patterns. It's a good book. If you don't need design patterns, don't run out and buy it. But if you need a book for a design pattern, I'd say it's worth checking out. I liked it. But I've got a couple links at the end of the slides which actually list out all the design patterns with sample code. So unless you need it for a class, I wouldn't necessarily rush out and buy it. So this idea of a design pattern then. I think I've said the word design patterns about 30 times already. What is it? Basically, it is a way of representing code where we have a very common issue that we need to solve, and we can apply a design pattern to solve it. So this is basically, you can think of it like a set of coding practices, a class diagram demonstrating a particular construct to solve this problem. But basically, you're going to apply this thing to your problem in generally object-oriented design. Key here is this is a proven solution. So I'm going to show you the model view design pattern here in a minute. But the one thing that I should kind of mention is that this is all going to be tied in with object-oriented programming, which is nice because you all did Java already, or you probably have done Python or Java or C++ or C# or one of these languages, which are kind of object-oriented focused. And design patterns play very, very nicely with them because they take advantage of inheritance and encapsulation and all of these common OOP things that we have. The thing I will say though is, can you do this in C? A very procedural language where we don't have classes. And you absolutely can. which is kind of a cool thing to think of, that all of this really high level like time saving things that we can do, you can do in C. You just have to be very good with pointers. Because a lot of these rely on like function pointers, and if you don't know what a function pointer is, it's the barrier that keeps a lot of people from liking C. Basically, you just have a variable with a memory address, and that address points to an actual block of code, so that's a function pointer. Fun to learn about if you've never done C. So we have proven solutions, and these are basically structures or communication solutions. So the two questions here, what do we mean by proven? How does communication fit in? Proven means that we have seen these design patterns emerge over time in software engineering. Basically, we know that these things exist just based on what other engineers have done. So we've looked at history. And communication can mean two things. It can be communication between like objects, classes, entities. So how do they all communicate together behind the scenes to form this pattern? It can also be human-to-human communication. So if I tell you, go implement the facade pattern, maybe you don't know what facade is yet because we haven't talked about it, but you could look up the facade pattern and you're like, oh, okay, it's this class acts as a front end to these classes. I just have to do this, this, and this, and then it's done. Basically, it's a language that we can all speak, which is kind of nice. It's a common terminology. So why do we care? We're going to focus on code reuse. Code reuse is a big topic right now in the software engineering field because it saves you time, because you can reuse old components. They've already been validated, so we know that this code works. And ideally, you're saving yourself time and money from a project perspective. So code reuse is kind of a big deal for us as software engineers. Common terminology in team communication, again, exactly what I mentioned. Go implement a singleton. Okay, by the end of this lecture, you will know what a singleton is, or at least this module. But it's a common terminology thing. Also, it improves modifiability and maintainability. So, like I said, these are kind of high-level concepts, sometimes very abstract, relying on OOP tricks, but they make life easier. Let me give you an example that I gave this morning because I was quite happy with it, but I forgot to save the images, so you get to watch me looking it up again. All right, any of you ever hear of the model view controller? So this is a pattern or an architecture depending on your viewpoint. I like considering it a pattern because you can apply it anywhere. I didn't want to click that. Or yes, I did. This one. So if you've ever done a website, for instance, you might have heard of the model view controller architecture. You can apply this to any software problem, though, that involves data and a view, like basically a front end. So mobile apps, model view controller, Unity projects, model view controller. Basically, it's a very common pattern that we have here. So let me pull up a example that's also good that I can talk to. It's not the one I want. We will just use this one. All right, so why is this important? Pretend like you've made your first website. You made your awesome Angel Fire GeoCities portfolio page in the late 90s. You just put some raw HTML up there, add some cascading style sheets to pretty it up, and maybe a little bit of PHP on the back end to pull something out of a database. Like maybe you're doing a login system or your first ever blog. And then of course you got to have that under construction GIF there while you are working on it, because otherwise how is it an Angel Fire website? Look at that, I searched for it recently. There we go. Need one of these. That's too pretty. There we go. That's hot. We need this. Okay, so we're working on our web page. Very simple application, right? Straight up basic page. Okay, well, you get some experience, you like web development, you go to work for a web development company. Cool. They want you to build some more web pages. Only thing is now it's not a little simple page, it's a massive web application with many different pages. You might have different database representations behind the scenes. You have lots of ways for the user to kind of traverse the website. maybe even some internal logic that kind of pushes data from place to place. And all of a sudden, your one-page script, right? Maybe you've got some PHP code and then some HTML code and then some PHP code, HTML, all kind of dynamically generating in one place. That doesn't work when you scale up. I mean, it does work, but it's a massive pain in the ass to maintain and update and fix if something goes wrong. And why do I say that? Because you're going to have to make changes everywhere to fix whatever updates you need to make, right? It's not all in one place. So what this model view controller does is basically it separates out things. Your view is just the front end. You don't care what data is coming in, you just have placeholders for stuff. Your view is going to have all your nice CSS code, you know, your frame sets, since we're talking about 90s era programming. Obviously divs and flexboxes and all that fun stuff now, but it's just the front end, no data. Data's coming in and getting put into slots, but you don't care what's happening behind the scenes. Likewise, your model, this is your data structure. How is data formatted? Or how is it pulled out of the database and kind of represented internally in your application? So we have a data model. We might have multiple data models. Then the controller, how do we route things, right? So the user visits eric.com/shopping cart/update/item 5. I know that they want to add a new item to their cart, right? The controller takes that information from the view, routes it to the model, gets data from that thing, brings it back and returns it to the view. Why is this important, right? This sounds super complicated. Well, let's say we swap our database. We go from MySQL to MS SQL or to a graph database or a document database like Mongo. The view doesn't care. We don't have to update our front end because it's all abstracted out. We update the controller if we need to, right? Maybe you have to point at a new database or something like that, but the model is the one that has to be changed because it has to do different get operations, right? Instead of select everything from orders, now it's, I'm trying to remember what there was special syntax for the graph database. It was like a new internal language, but I think document databases, you can still kind of use SQL, right? You just, or no, it's, shoot, it's jQuery calls. It's been a while since I've done Mongo. But you're getting data out in JSON format, basically, right? So you're getting documents. You're not getting tabular relational database rows. So the only thing that changes in this particular instance is the model, really, right? Maybe the controller, but mostly the model. You don't have to update every single web page anymore. You just maybe change the view if you need to, but all the work's done here. What does that look like from a class perspective? So here we have a model view controller class diagram, package diagram, class diagram, sequence diagram. Look at that, all this fun stuff here. But basically what we have is the view would update for the view. The view might tell the controller, hey, this is the page we're at and this is what the user is requesting. The controller tells the model, hey, pull out this data and send it back to the view. Before, in our straightforward brute force basic application, this is all one big class, for instance, maybe two. But here we've separated things out and they're responsible for themselves. A little bit of extra effort at the front end to do the separation, but think about maintaining this and extending it. If we have to add a new web page, we just add a new view. Controllers in the model stay the same. So it makes life honestly a lot easier if you get to that point. And if you have no idea what I'm talking about in terms of like web development stuff, I know I want to say like Angular and React probably have some variant of that in there. PHP wise, there's like Cake PHP or Code Igniter. And these words that I'm throwing out there, basically, these are big frameworks that you would install on your web server. And it's a lot of overhead, but it implements this design pattern very, very nicely. Hopefully it makes life easier, honestly. Alrighty, so where I talked about earlier why we use them and how we're going to use them, we're going to basically take advantage of all these object-oriented tricks that we have, right? If you define a new Java class, you can very easily create subclasses, you can encapsulate things, you can hide things or make them public, right? And hiding's making it like protected or private. You control who has access to what field. You control how you route from class A to interface to class B, C, and D. All of these object-oriented little tricks are what kind of makes design patterns possible. And again, we don't have all this fancy stuff in C, but you can do it in C with pointers. Classes can be hacked together in C, for instance, using some extra trickery, and I'm sure there's language extensions to allow it to happen. My background in C is the ANSI C, the safety critical C, with absolutely no classes ever. How dare you even consider that? You're going to get structs and you're going to like it. So that's where we're at. So how do we describe these things? And I'm talking about them like they're basically a dictionary or a lookup table, because that's basically what they are. So for that, we have to kind of specify how we construct a design pattern. Thing to keep in mind too, people who created this, let me pop forward here a moment or two. The people who wrote that textbook, the Gang of Four as they're called, they created 23 patterns. Or sorry, they cataloged them. They didn't create them. They existed already. But they described them with these basic fields. And why do I say that? Well, people are still adding design patterns, right? It's not a end-all be-all list. New ones are being discovered as time goes on, as groups are studied, as new programming language concepts come into play. I'm sure as quantum computing starting to take off, we'll get a whole bunch of design patterns regarding quantum gates when we get to that point, right? So this is an expanding list. It's good to know how to talk about them. So what comprises a design pattern? Obviously the name, right? We need to name it something cool and classify it. Structural, behavioral, creational. We'll talk about that momentarily. But first and foremost, why do we have this pattern? What is the problem being addressed by it? Right? Model view control. This is something where we need to separate out our components. Likewise, we'll talk about a singleton. You get a single instance of a single class, and that's all you ever get for that class, right? You can have any number of other classes, but this one, there's only one instance ever controlled in the system. That has some very nice benefits of being, common to every single thing. Common examples, a random number generator. You want one instance of that for everybody so that we all use the same random number distribution. But that's the problem that you're solving. You need a commonality in place, so that's the intent for that one. We need a structure. So every design pattern gets a UML representation. Why? Well, we need to know how to implement this. We don't need it to be language specific. We can do this in Java, C#, Python, whatever you want. But if you give it to me in UML, I can translate that to my language of choice, right? So what classes are going to be necessary? We also need to know which classes are participating. So how do we hook this design pattern in? What are the important classes to include? What are the responsibilities in this pattern? How do they collaborate? Are there aggregations? Are there associations, compositions? What comprises this pattern? And we're kind of going bullet by bullet here. Think of these ones as basically, what is your class diagram? How do they relate to each other? What attributes are necessary? What visibility levels are necessary? What functions are necessary? Basically, how do they all interact, right? Everything we've done with class diagrams applies here. Interestingly, we also describe consequences. So I'll stop moving so that we can see the bottom here. What are the trade-offs of this pattern, right? That's the field of software engineering, is the field of trade-offs. If I do this, I'm going to do it for this benefit, but I'm going to get this negative effect by doing it. So a trade-off might be it's super complicated, but it runs 100 times faster. Or it's not complicated at all, and yet we can never update it because it's so convoluted. So what's the trade-off here? Or what's the benefit? Like if it's a net benefit, what is it? Last but not least, what is the implementation suggestion? So if I'm going to implement a facade pattern, you're probably going to need an interface. I might have some sample code to describe how to create this thing. But basically, here are all the little gotchas for creating this pattern. And if you zip ahead to the last slide, I've got a link to a Wikipedia article on all of these things, and you can follow links to your language of choice. I also have a list of them in Python with code baked right into those links. So basically, these patterns are out there and they exist with very easy to implement code bases. So these are all the things that basically describe a design pattern. And if you ever come across a pattern that you think has never been described before, you can basically propose it as a new pattern, fill out all these fields, and I think you can propose it to, I don't remember which, if it's a governing body or not that kind of collects all the design patterns, but basically there's a database out there of patterns, commonly accepted patterns, I guess. So I showed you this slide already. Basically these people, group of researchers, figured out this design pattern catalog, found 23 of them. There are now more than that, but they already exist. And what are they? Well, we have a whole bunch of them. So we have the creational side, we have the structural side, and the behavioral side. And I'm just throwing these terms out like you know what they mean. Basically, structure, think of your class diagrams, your structural UML diagrams, right? They care about how things are put together. It's the static side of things. The behavioral, this is going to be your interactions, your program flow, responsibilities, coordination, all that kind of thing. How do things interact, right? The dynamic side of things. Creational, how do we instantiate things? How do we abstract creation or instantiation out? So 3 high-level categories there. We're going to talk about Singleton, we'll talk about facade, we'll talk about observer. Basically, we have a whole laundry list of different patterns. And again, these are all in existence because they solve a particular problem. Are you going to know which pattern to apply when just off the top of your head? Probably not, right? I mean, if you have a general problem to solve, either you're going to have an engineer suggest to you, hey, you should use this pattern, then that's in your, kind of your tool belt for later on. Or you start looking up your problem, start searching Stack Overflow or what have you, and people are like, hey, just use the structural bridge pattern for this, and you're golden, right? So it just takes some practice to get used to these things. And again, they all have idiosyncrasies with how you implement them and all that fun stuff. Alrighty, so what I will do is end here, and we're going to talk about 3 different patterns on Monday with some code examples, and it's going to be lots of fun. Does anybody have any questions at all about UML, the beginnings of design patterns, life in general? Basically, I don't want to get too far into the other examples because I want us to be able to cover it all in one class. So if you don't know what this figure is, it's from Stormlight Archives, fantasy book series. And as a preview, I guess, while we're waiting to see if anybody has any questions, we have Java examples. We also have Python examples in the slides. So it'll be fun on the bun. And the spoiler is that I'm going to refuse to do the Java ones because I hate Java so much. That's another story for another day. What language will the patterns be in? Java sucks, yes. You can do it in whatever language you want. That's the nice thing about software engineering, is you can apply these in any way, shape, or form. All right, so I've got code for Java and Python in these slides. There is nothing stopping you from doing this in C#. Hey, if you like Java, that's great. I'm happy that people like Java. I have a personal predisposition about it that should not infect you at all. Use Java if that's what you're comfortable with. I prefer C and Python. That's just me. I also don't mind C#, which is kind of strange to say. I actually did my master's thesis in C# for some reason. But I mean, I know you all have to learn Java anyway, so I shouldn't badmouth it too much. Maybe let me set the context here before we get too far off the rails about how awful of a person Professor Fredericks is. I came out of the world of C and C++ as an undergrad, so I had a massive appreciation for memory management and pointers and everything. And then I started learning Java, and I realized that not only does it handle all that for you, it doesn't do it that well. I'm sure it's fine now, but when I was looking into Java way back when, it colored my perceptions. I should probably change my mind on that one because that's how you get stuck in singular thinking, right? Java's fine. Oh yeah, you learned Java first. I learned C first. It's just a perspective thing, that's all. Hey, I mean, best game in the world ever was made in Java, right? RuneScape? Oh, come on. Java's got to be good. Okay, Minecraft too. I don't know much about Kotlin. So, I know that's the new exciting thing with Android development, right? But I haven't actually looked into it yet. I really should. Android development drives me nuts in like pure Android Java. But it's not really a Java problem, it's a package problem. Hey, you don't have to use Android Studio, I like that. Yeah, I should learn Kotlin, that's the new exciting thing. It looks kind of Java-esque, huh? Print line. Maybe this will actually get me to build that $1 million app idea that everybody pitches me. Friends pitch me, I guess. Ooh, Lambda functions. So is this like a combination of Java and Python then? This looks like Visual Basic. Huh. Yeah, sorry, class is over. You guys don't have to hang around while I look at this, but I keep meaning to look into Kotlin and I never do. This so looks like basic. Surprised there aren't line numbers that you have to call. Huh. All right. Well, I hope you all have a wonderful weekend if you're still hanging out here. Productivity boosters. Ooh, named arguments. This is so a bastardization of Python, isn't it? Oh, they even do this? Yeah, that's so Python. Come on. Come on now. Although maybe it's less annoying than Java, Android Java is, so. Mobile cross-platform, I like that. That's good. So this is multi-platform. So is this, oh, what was the Cordova? The transpiler between Android and Apple and Windows Phone? Maybe I will have to look into this then. Cool. All right. Well, I will see you all Monday. Hope you have a wonderful weekend. And this has been Angry Old Man Rants at Java for an hour. Tell Professor DeVries when he teaches this again next year how much everybody loves Java. Or how much I love it. Yeah, I'll have to check this out. If it makes mobile development easier, I am all for it. Mobile development is such a pain in the butt sometimes. Cool. Server side. Oh, it's even got a server side language. Hey, how cool. All right, enough of that. So have a good weekend. Bye, everybody.